Imagine this. You push off from the side of a spacecraft, and you start to fall. Not down, not up, just into nothing. Forever. That's exactly what happened on February 7, 1984, when astronaut Bruce McCandless detached from the Space Shuttle Challenger at an altitude of 510 kilometers above Earth, and became the first human being in history to float freely in open space with no safety tether whatsoever. Completely alone, in absolute silence. Nothing between him and instant death but a few centimeters of spacesuit fabric. What was supposed to be a routine test of a jetpack maneuvering unit became something far more profound. The most visceral, most documented freefall into infinity that humanity has ever witnessed. And that single image, one man, utterly alone, suspended between the planet and the void, captures the truth of what space actually is. Not a beautiful backdrop, not a distant dream, something fundamentally, irreversibly hostile to everything that lives.
Space is vast, and that statement is so overused it barely registers anymore.
But here's the thing. Space isn't just geometrically enormous. It actively breaks our ability to process reality. If you had to describe the entire cosmos in a single word, that word would be nothing. A potentially infinite nothing. And yet, paradoxically, that nothing is packed with monstrous structures and energies that shatter every framework our minds have built. Threads of thousands of galaxy clusters, each one containing hundreds of billions of stars, weave together into patterns so grand that our brains simply refuse to accept them as real. There are regions of space so dense, so impossibly massive, that the laws of physics as we understand them stop working entirely. Matter behaves by rules we haven't even begun to write down. And here's the haunting part. When you step outside on a clear night and look up, you're only seeing the nearest neighbors, a handful of stars within a few light years. Everything else is hidden in an endless blackness, lurking just beyond what our eyes can reach, patient and enormous, waiting. And despite all of that, or maybe because of it, we feel an inexplicable pull toward that darkness. Since the very beginning of our species, we've turned our faces to the sky and tried to make sense of what lies beyond the horizon. We used the stars as a compass to navigate vast oceans, to know when to plant and when to harvest. We drew our gods into the star patterns, stitching constellations across the night sky. Our oldest attempt to impose meaning on the chaos hanging over us every single night. We didn't know what was out there in the deep, but we felt in our bones that it mattered, that it changed everything. Over time, we built telescopes that stretched our vision and let us peer through the dark to find worlds so alien and terrifying that their existence once seemed impossible. And then, in the modern era, we dared to take the first, still trembling, steps into that emptiness, sealing our fragile bodies inside spacesuits and metal capsules designed to fake the conditions of home. Because there is not a single point beyond Earth where we can survive on our own. Our world, seen from out there, is a microscopic oasis of warmth and life in an infinite black desert, as significant to the rest of the universe as one bacterium lost somewhere in the middle of the Pacific Ocean. You're watching Planet Instinct, a channel about the mysteries of nature, the universe, and the things our minds genuinely refuse to accept as real. If you want to understand just how hostile this universe truly is, and what makes Earth the only place where you can take a breath without dying, hit that notification bell right now. Because in the videos ahead, we're going to cover things your textbooks quietly skipped over. Don't miss them. We exist on a tiny speck of the known cosmos, clinging to the surface of a small, rocky planet tucked into the arm of an unremarkable galaxy. And even on this little patch of rock, we can only survive on land, which covers just 29% of the planet's total surface. But it gets tighter than that. Of all that land, only around 43% is actually livable for human beings. The rest will kill you without hesitation. the scorching heat of the great deserts, the deadly cold of the polar regions, the dense and venomous tangle of the deep jungles. Earth is remarkably creative when it comes to ending lives. You can die of thirst, drown in a flash flood, fall from a cliff, burn in a wildfire, or be struck by lightning from a clear sky. A lion, a tiger, or a bear can end you before you see it coming. You might pick the wrong berry, pet the wrong snake, get bitten by the wrong insect, or simply board a flight to Australia, which seems to operate on its own dedicated extinction program. Volcanic gas, a blood clot in the brain, a rat bite fever. These are all real, documented ways the planet has ended human lives, entirely free of charge. And sooner or later, Earth wins, every single time. No one has ever outlasted it, not once. And yet, for all its lethal creativity, this is the only place in the entire solar system where we can exist at all.
Picture this for a moment. You teleport to the surface of Mercury. You'd lose consciousness within 20 seconds. Pure oxygen deprivation, nothing dramatic. If you land on the sun-facing side, your body starts to cook at 800 degrees Celsius. If you land in the shadow, instant frostbite at minus 290 degrees. And honestly, that's one of the gentler options. Raw open space is its own special nightmare. Your skin would begin to boil, and the dissolved gases in your bloodstream would bubble up like a shaken soda bottle. Death arrives before your brain can finish forming the thought. Venus is worse. You wouldn't even get the chance to suffocate because the air temperature there sits at 867 degrees Celsius. Immediate combustion. And simultaneously, the atmospheric pressure, 92 times that of Earth, would be crushing you like you'd been dropped beneath a kilometer-tall column of water. Mars looks promising at first glance. Some days are relatively mild, but the atmospheric pressure is only 1% of Earth's, and there's almost no oxygen. You'd simply fade out. No pain, no drama, no chance. Jupiter has no real surface at all. You'd fall through layer after layer of thickening gas until the pressure compressed you, literally, into something resembling a diamond. Saturn offers a similar fate, but the ammonia clouds would sear your lungs long before the pressure finished the job. And on Neptune and Uranus, those frozen giants, at minus 371 degrees Celsius, your body wouldn't freeze. It would vitrify, instantly, permanently. Scared? Good. That means you might have what's called astrophobia, and it's more common than you'd think. The word itself comes from the Greek astron, meaning star, and phobos, meaning fear. Technically, it refers to a fear of stars specifically, but in practice it covers the entire spectrum of cosmic anxiety. Interestingly, one of Mars's moons bears the name Phobos, literally fear in Greek. It's been circling our solar system this whole time, staring back at us from the dark. Astrophobia shows up in all kinds of forms. A city dweller used to the permanent orange glow of light pollution who suddenly finds themselves under a truly dark sky, every star blazing, the Milky Way overhead, can be overtaken by a sudden, unexpected wave of panic. That's mild astrophobia, the overwhelm of scale. Some people grow anxious during Mercury retrograde. That's a version 2. The old belief that people go mad during a full moon, giving us the word lunatic, is another ancient echo of the same fear. In the Middle Ages, comets were read as omens of catastrophe, and that dread is literally baked into the English language. The word disaster comes from the Latin for bad star. But there is one form of astrophobia that runs deeper than superstition, deeper than religion. It's not born from ignorance, it's born from understanding. This is my favorite part, cosmic existentialism. Have you ever lain on your back in the grass on a clear night, staring up at the sky and suddenly felt something shift inside you? That moment when the sky stops being up
and you realize you're not looking upward at all. You're looking down. Down into a bottomless drop into an eternal void. And the only thing keeping you from falling into it is gravity, that invisible force we still don't fully understand, pressing you against the surface of a spinning rock. That perceptual shift is one of the most transformative psychological experiences available to a human being. I genuinely recommend it to everyone. And you don't need anything for it, no substances, no equipment, just a dark sky and an open mind. In space, that feeling isn't a metaphor, it's physical reality. There is no up, there is no down. Space is perfectly uniform in every direction, and all that stands between you and an infinite freefall is gravity, the force that Einstein described mathematically but never fully explained. Here's what truly chills the blood. Travel just 8 kilometers straight up from where you're sitting, and you die. 8 kilometers. The distance you could walk in a little over an hour. Beyond that line, space begins, and space kills. Everything past that invisible boundary is death in a different package. 8 kilometers. That's the entirety of the margin between you and the void. In the scale of the universe, it's less than a rounding error, and it's everything. Stop. Before we go any further, right here, at this exact point in the video, you are standing at the edge of the darkest part. Most people won't make it to the end. Most will stop right here, because what comes next is too real, too vast, and too uncomfortable for a good night's sleep. If you want the truth about the actual size of the universe, about why we're probably alone, or about why that might be even more terrifying than not being alone, subscribe to Planet Instinct right now. This is the channel that doesn't soften the scale of reality. Hit the bell so you don't miss what comes next. Let's keep going. Our sense of the universe's scale is fundamentally broken, because the human brain simply was not built to process numbers this large. We say, 1 billion light years, and we think we understand. We don't. Light travels from the sun to Earth in 8 minutes. To cross the entire Kuiper belt and exit our solar system, it takes roughly 8 hours. 1 light day is 3 times the radius of our entire solar system. 1 light year is 365 times longer than that. The nearest star to us, Proxima Centauri, sits just over 4 light years away. The North Star, which looks so close and bright in the sky, is 450 light years away. The most distant star visible to the naked eye, V762 in the constellation Cassiopeia, is a supergiant sitting approximately 16,000 light years from us. When we look out at the Milky Way, our solar system sits roughly halfway between the galactic core and the outer edge. The radius of our galaxy alone spans between 25 and 28,000 light years. Its full width stretches 100,000 light years across. That is one galaxy, and there are hundreds of billions of them. The nearest one, Andromeda, is 2.5 million light years away. That's 25 times the full length of our own galaxy. Just the distance to the neighbor next door. We belong to something called the local group, a cluster of galaxies roughly 10 million light years across, containing the Milky Way, Andromeda, and a few dozen smaller companions. That local group is itself part of the Virgo supercluster, a sprawling structure holding about 100 galaxy clusters and 10,000 individual galaxies, stretching across 110 million light years of space. And that supercluster is just one fragment of something even more staggering, a structure called Laniakea. Laniakea brings together the Virgo supercluster and the Hydra Centaurus supercluster, and it's slowly drifting toward a gravitational anomaly known as the Great Attractor, a region whose true nature is still actively debated by scientists. Laniakea stretches 500 million light years in diameter. Not a planet, not a galaxy, a single, coherent structure, and just one of many. Zoom out even further, and the universe itself dissolves into a system of enormous filaments and voids, regions of near total emptiness. The Boötes void, for instance, spans 300 million light-years. It is simply a gaping hole in the fabric of the cosmos, containing almost nothing. Put it all together, everything we can observe, and the known universe stretches roughly 93 billion light-years across. 93 billion. And that's only what we can see. Given the absurd scales we've just walked through, it seems almost logical to assume that life must exist somewhere else out there. Even if the probability of life arising in any given star system is vanishingly small, even 1/1,000,000%, multiply that by trillions of star systems, and the resulting number is still enormous. Arthur C. Clarke once captured this with unsettling precision. There are two possibilities. Either we are alone in the universe, or we are not. Both are equally terrifying. And he was right. If the universe is populated, that means potential threats exist. Civilizations out there whose intentions we know nothing about. The dark forest theory proposes a chilling logic. Any sufficiently advanced civilization, upon detecting another, will destroy it before it becomes dangerous. The silence in the radio spectrum isn't proof of emptiness, it's proof of camouflage. But if we truly are alone, if there's no one else within thousands of light-years in any direction, then we are adrift in an infinite void, without meaning, without witnesses. As astrophysicist Ellie Arroway once put it, it would be an awful waste of space. So vast and so precise a waste that sometimes it feels less like an accident and more like a design. What if the universe is being generated as we explore it? When the Hubble Space Telescope was pointed at a tiny dark patch of sky in 1995, no bigger than a grain of sand held at arm's length, it found thousands of galaxies there, each one holding billions of stars. Perhaps those galaxies didn't exist until we looked. Perhaps the large-scale structure of the universe, the cosmic web, the filaments, the voids, only crystallized once we developed the tools to map it. What if consciousness is the rendering engine? What if what we experience as reality is just a set of ones and zeros running in something we can't even imagine? The idea sounds insane. But it's no more insane than the physical facts about the universe we just laid out. The simulation theory is compelling precisely because it answers the most uncomfortable question of all. Why is everything this absurdly enormous and yet so flawlessly organized? There is, however, another explanation, less fantastical, possibly more frightening. It's called the Great Filter. Wait, if you've made it this far, you're the kind of person who wants the real picture of the world, unfiltered, undiminished. Planet Instinct is built for exactly that. Every week, new videos on what science actually knows about our planet, our universe, and ourselves. The things that quietly reshape how you see reality. Subscribe, and don't lose track of what's coming next, because the next video might be the one that permanently changes how you look at the night sky. The Great Filter offers this explanation for the silence of the cosmos. Simple life, bacteria, single-celled organisms, may well be widespread throughout the universe, but intelligent life keeps running into a wall, a barrier so steep that almost nothing makes it past. That wall is the Great Filter. The only question is whether it lies behind us or ahead. Some scientists believe we've already cleared it. Earth is 4.5 billion years old, and single-celled life emerged here relatively early. But the leap from single-celled to multicellular life took 2.5 billion years. That transition is so statistically improbable that it may itself have been the filter. Most planets with life may have stalled right there, never taking that step. Other researchers hold a far darker view. The filter is still ahead of us. Maybe it's a catastrophic cosmic event, a gamma-ray burst that strips away an atmosphere in hours. Maybe it's a predatory alien civilization operating on exactly the logic the dark forest describes. Or maybe the answer is simpler and more unsettling. Maybe intelligent civilizations inevitably exhaust their planet's resources and destroy themselves. Intelligence, in this view, isn't the crown of evolution. It's a mutation, a cancerous pattern of consumption, always taking more than the system can replace, that ends, sooner or later, in collapse. If the size of the universe is one form of absurdity, the age of the universe is its perfect companion. These two dimensions, space and time, are fundamentally linked, and together they form the fabric of what we call reality. Let's be direct about it. The average lifespan of a biological species on Earth runs between 5 and 10 million years. After that, extinction, evolutionary replacement, or fragmentation. Intelligent civilizations might do better, or worse. Let's say ours lasts another 10 million years. That's an optimistic scenario by almost any measure. Against the backdrop of a 13.8 billion-year-old universe, that interval is statistically invisible. It is less than 1% of 1% of cosmic history. We flicker. Now add this. Even if life is widespread, even if every star system at some point sparked into intelligence, all those civilizations arose and vanished in different windows of time. Different eras, never overlapping. We may not be the first. We are almost certainly not the last. But we are here, right now, in our tiny sliver of time. And that is all we have.
And here we are, at the heart of it all.
We are a species living on a paper-thin film of survivable atmosphere, on the surface of a small planet, orbiting an ordinary star in one of hundreds of billions of galactic arms, inside one of hundreds of billions of galaxies, within the observable portion of a universe that may itself be just a fragment of something incomparably larger. We exist in a window of time that by cosmic standards is shorter than a single heartbeat. We are not at the center. We are not in a special place. We are not the goal. We are a statistical accident of organic chemistry that somehow developed consciousness, and then started asking questions. And the most frightening question of all is this: why? There is no answer. Maybe that's exactly why we keep looking up, why we keep building telescopes, launching probes, designing spacesuits, and charting routes into places that would kill us the moment we arrived. Not because we expect an answer, but because the search itself is the point. Because this is all we have, us, human beings, face to face with an immense and consuming darkness. And as long as we keep asking questions, we exist. The moment we stop, we disappear. So keep asking, keep looking up, and subscribe to Planet Instinct, because that's what we do here every single week.